Good evening everyone. I am Souvik Pal. Today I am going to discuss about the matrix and determinants. That is one of the important topics in both JEE Mains and JEE Advanced syllabus. As you all know that there are many such topics are included in JEE Mains and Advanced syllabus such as set theory, probability and distribution, matrix and determinant, coordinate geometry, vector calculus and many other such things. So today our topic is matrix and determinants. First, what is matrix? A matrix is basically a set of numbers that is arranged in an array, and where the number of rows equal m and number of columns equal n. So if we can say that there are number of rows equal 3 and number of columns equal 2, so we can say that the order of the matrix is 3 equals 2. Here you can see an example that here the number of columns are 3 but number of rows are 2. So the order of the matrix is 2 cos 3. So there are different types of matrix such as row matrix, column matrix, square matrix, null matrix. Row matrix is basically the matrix where the number of rows equal 1. Similarly, column matrix is the matrix where the number of columns equal 1. Square matrix is the type of matrix which is the most important matrix in our syllabus, where the number of rows and number of columns equal. And null matrix is the where the all the elements of the matrices is 0. Here ij represented, I means the ith number of row that goes from 1 to m, and j represent the number of columns that go 1 to n. And here you can see that many other matrices such as diagonal matrix, scalar matrix, upper diagonal matrix, they are both basically the square matrices. Diagonal matrix means the only there are the diagonal element, except all other elements are 0. And scalar matrix is the if we add a constant, such as if we add 5 to a matrix, then it should be added to all the elements. And upper triangular matrix is the type of matrix where there is the only diagonal element and only the upper part of the diagonal element are there, and lower part of the diagonal element are all 0. Similarly, for lower triangular matrix, the upper part will also be the 0. And here are the most important matrix is unit matrix, where all the diagonal elements is 1. So here there is another thing, the trace of matrix. The trace of matrix is basically the sum of the all diagonal elements. So now come to the algebra matrix such as matrix addition, subtraction and matrix multiplication. So among them, matrix addition, subtraction and multiplication, matrix multiplication is the most important topic. So matrix addition or subtraction is basically that if we add two matrices, there is most important thing, the order of the matrices should be same. Then we can add or subtract between the matrices. So here you can see that the first element of the first matrix and first element of the second matrix, they are added together. Similarly, the last element of the first matrix and the last element of the second matrix similarly added together. Here you can see an example. So now come to the topic on matrix multiplication. Matrix multiplication can be done by two ways. One is scalar multiplication, one is matrix multiplication. Scalar multiplication is basically if we multiply a constant to a matrix, it should be multiplied to all the elements. Look, here 5 is multiplied to the matrix and the first element changes to 5 into 2, 10. Similarly, all the elements changes. Look at the last element, 5 into minus 6, that changes to minus 30. Now the most important topic is matrix multiplication with another matrix. Matrix multiplication is possible if and only if the number of columns in the first matrix is equal to the rows of the second matrix. Then only matrix multiplication is possible. Here you can see the matrix multiplication is basically, here you can see that it is a 2 cos 2 matrix. Both are 2 cos 2 matrix and the resultant matrix should be 2 cos 2. So matrix multiplication done in this way. A11 means the first element to the first element, and the second element means the column wise second element, and the row wise second element should be added together. Here you can see an example. Here is 2, 3, 4, 5, 6, 7, 9, 4. Firstly, we multiply 2 into 6, that comes to 12. Then we multiply 3 into 9, that comes 27. And our first element changes to 39. Similarly, all the elements changes together. Here is the matrix multiplication properties. If we added basically this is a C is a scalar. If we added scalar, so here is no change, that it is a associative property. Similarly for distributive property, identity property. Identity means if we multiply unit matrix to a matrix, it should be the matrix. And multiplicative properties of 0. Here there is a mistake, the term should be 0, that is not the A. So dimension property, I have said you that if there is a product of m cos n and n cos k, so the matrix is an m cos k matrix. The most important thing is commutative law of multiplication does not hold. Means for matrix multiplication, A into B is not equal to B into A. It is not possible in matrix. Now come to the transpose of matrix. Transpose is basically the interchanging between the row and column. So transpose is written as A, and in the superscript there is written T. So here you can see an example that it is basically a 2 cos 3 matrix, and it is changes to 3 cos 2 matrix. So here are the property of the transpose. First, if we transpose a transpose matrix, it should be our original matrix. And here is the addition property, multiplication, and multiplication property by transpose. So based on the transpose of matrix, we got another two matrices. One is symmetric, one is skew symmetric matrix. When the transpose of a matrix is similar to the original matrix, then we can call it as symmetric matrix. And when the transpose of a matrix is the negative of the original matrix, we can say that it is skew symmetric matrix. And the main condition is that they are both square matrix. So here are some special cases. If we add the original matrix and the transpose of the matrix, so the sum of the matrix is symmetric. And if we subtract the transpose of the matrix from original matrix, it is the skew symmetric matrix. And the multiplication of A and A transpose and A transpose A are symmetry matrix. Here the main difference is that first we say that AB is not equal to BA, but here they are same symmetry matrices. And the last is there is a condition, the relationship between the symmetry matrix, skew symmetry matrix, and our original matrices. Come to the another interesting topic in matrix, that is determinant. Determinants is basically a numerical value that is a scalar. Here you can see that there is an example of order 1 matrix. Here is only single element, so the determinants of the matrix is the number itself. And but when it is the 2 cos 2 matrix, then the determinant should be the cross multiplication, means A11 into A22 minus A12 A21, means there is a cross multiplication. And when the order is 3, there is a formula. By using the formula, this formula is similar to the area of the triangle formula. After you can see that how to find the area of a triangle by using the determinants. And there are the minors and cofactors. Minor is basically if we want to calculate the minor of the first element, then we need to delete the row and the column that added to first element. Here you look that there is a first element is A11. If we calculate the minor of the A11, we need to delete this row and these columns. means sorry, these columns and this row. So there is only left the A22, A23, 32 and 32. So by taking the determinants of these four, means of this small matrix, we got the minus of the A11. And there is a rules of the cofactors. Cofactors is basically none other than only there is a term minus 1 to the power I plus j. I means the number of the, means here you can see that 1 means the, it is the I is 1, j is 1. I means the number of rows that goes to 1 to m, and j means the number of columns that goes 1 to n. So here you see that there is an example, and here you see the minor of 2 is minus 111. So we calculate the minus of 2. So holds the 2 and delete the row, columns and row. You can see that 8 into 6, that is minus 48, minus 9 into 7, 63. So we got the minus 111. And cofactors of 2 similar to its minor, because it is our first element. So minus 1 to the power 1 plus 1. So the term should be 1, and 1 into minus 111, that is minus 111. So here you can see there are some properties of determinants. If the row or columns are interchanged, the value of determinants remain unchanged. And if any two rows or columns are interchanged, then the only its signs are changed. If any two rows or columns of a determinant are same, then the determinant value is 0. You can learn about that in your graduation. There is a term called rank of the matrix. And if any two row or column of the determinants is multiplied by a variable k, then this value multiplied by variable k. And if sum or all elements of a row or column are expressed as the sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. So now the most important topic is adjoint and inverse of a matrix. So how to find the adjoint of a matrix? So firstly, to find the adjoint of a matrix, you firstly need to find the minors. Then after getting the minors, you will easily get the cofactors. Then by only transpose the cofactors, you will get the adjoint of the matrix. So by using the adjoint, we need to find the inverse of the matrix. So to calculate the inverse of the matrix, firstly we need to calculate the determinants, and then adjoint of the matrix. And then there is a formula. You can see that there is a formula. A inverse is equal 1 by determinant of A. Mod A means the determinant of A into adjoint A. So here is an example of the inverse of a matrix. So if you do calculation, you easily get the value of the determinant and adjoint. So after solving, you got the inverse of the matrix. Here it is the solution. And now the another topic is area of the triangle. As I told you before that we can find the area of the triangle by using determinant also. Here is the formula. Here x1, y1, x2, y2, x3, y3 are both vertices. So here is an example. If you solve it by using the formula, you got the area of the triangle is 35 square units. So that is the last topic, is the system of linear equation. So we can also solve the linear equation by using determinant. Here there are three equations and three unknowns. Number of equations should be number of unknowns so that we can solve the equation. Here you can see that there are x, y, z are unknown. So to solve the linear equation, firstly we calculate the determinants. Firstly we calculate the main determinants. Then for d1, for calculating value of the x, here when you calculate the d1, we need to remove the coefficient of x. And here you can see that there is no a1, a2 and a3. All other terms are there. Similarly d2 for y and d3 for z. So before that we need to check the consistency. Consistency means if the main determinant is non-zero, means the determinants calculating by the coefficient of x, y and z, then it has only one unique solution. If all the determinants are 0, the system has many solutions. But if the main determinant is 0 and all others are non-zero, there is no solution. The system is inconsistent. Here is an example. By solving, you will get the value of x, y and z. X is 1, y is minus 1 and z is also minus 1. So thank you.